configure the ADC in watchdog mode or scan conversion mode. Here you can see. For example, in this figure, you can configure analog watchdog to monitor analog voltage. So this watchdog monitor, I think in the previous slide I had shown somewhere a watchdog. Yeah. So this watchdog timer, the watchdog timer will always compare the real-time measurement against the threshold value. So that is the purpose of this watchdog monitor. So that is what mentioned here. So here you can see, you can configure analog watchdog to monitor analog voltage. So for example, this pin number 6 in the port A, that is used for ADC in. So you are receiving the ADC signal. And the threshold value I set up here, low threshold value as a 1500 and the high threshold value as 2500. I will show you how to set up this. It doesn't need to be this value. It can be any other value, but I'm just taking this for example. So it means whatever the value, measured value is between this 1500 and 2500 is the more safe area, guarded area. And if whenever the measured real-time value goes beyond this, for example, if it goes more than this 2500 or if it goes less than the 1500, then we need to have the alert signal. You can see here, this one, the analog voltage can be from 0 to 4095. We are talking in terms of digital level now. So it can be 0 to 4095, the maximum. But when this measured value is between here and here, 1500 and 2500, then we have no problem. Here it's okay. But when it goes less than 15 and more than 25, then we need to get alert signal. So then we need to generate this ADC interrupt. So it means like we are blinking this LED immediately. Okay, so this is the logic, the same like the one. You can take the heartbeat as an example. So this indicates maybe 70 and this indicates the 80 heartbeat. And you are measuring the heartbeat here using the sensor. The sensor is measuring the heartbeat, maybe wireless. So whenever the heartbeat goes less than the 70 or more than the 80, then we need to receive emergency signal from this microcontroller. So this analog watchdog is watching out the result. And for example, now I receive 90, then the 90 is greater than 80. 90 is greater than 80. 90 is the real-time measurement that is coming from the sensor. And the 80 is the standard one I set inside. That is the high threshold value. Then immediately the watchdog monitor will generate the interrupt signal from this ADC. It doesn't need to store this value in the memory, this 90. Now in this kind of situation, analog watchdog should immediately give the warning signal. So we can set up, it will generate the interrupt signal. This watchdog will generate the interrupt signal. This interrupt signal, you can use it for any purpose. You can use this one to activate the relay, or you can use this interrupt signal to enable the SMS or email, or just give into simple LED. So LED will start to blink. So it means something wrong. The measured value is beyond the reference values. So here you can see. So here the ADC1, in the ADC1 I'm using the channel 6 external input signal, and I am also setting up one pin at the output, because whenever the measured value goes beyond the reference value, I want the LED should be blinking. So I set up the pin number 7 in port B as the yellow LED in the GPIO pin. So now I go to the clock configuration. I am checking the clock speed. Everything is okay. The sys clock and the high speed clock and the prescaler value. And then I go to configuration. and then I go to this ADC because I selected this ADC. So I go to parameter settings. The parameter settings, I am checking if everything is okay. I enable this continuous conversion mode as enabled, and others are in disable mode. And then in the watchdog, remember we are talking about watchdog mode. So watchdog must be enabled. So enable analog watchdog mode. So I enable this, I click this tick mark. And of course the channel number 6, that is the one I selected. And then the threshold value. So the one we were talking about. So you can see here, the threshold value, I set maximum threshold as 2500 and the lower threshold value as 1500. And I can change this to any value between 0 to 4095. That is the maximum. So I can change this value, and here everything is okay. And the interrupt mode I also enable, because this watchdog mode is always watching whenever the measured value is between this 1500 and 2500, no problem. But if the measured value goes beyond these threshold values, then interrupt mode is enabled. So then this watchdog will generate interrupt immediately, and that interrupt will activate the LED. So that is the overall uh, goal of this program. So I set up everything here, everything is okay. And the continuous conversion mode, it means this will continuously check the channel number 6 and get the data and then perform the conversion, analog to digital conversion continuously. So whenever the value goes beyond this, then it will generate the interrupt. Okay, so what else? And then I go to the NVIC settings. So NVIC is the priority setups. So you can see here, I am having I am enabling this ADC1 and ADC2 global interrupts. This is very important. So you must go to this NVIC settings and then enable this one. You have to click this one and enable this. Then only the interrupt will be enabled to activate the LED. So by the way, I also want to tell one more thing. So here you can see preemption priority and sub priority. Last week we had seen about this preemption priority and sub priority. We had seen group 0 to group 4, group 0 to group 1, group 2, group 3, and group 4. In each group, we have the preemption bits, 4 bits, 1, 2, 3, 4. And then the sub priority, we have also 1, 2, 3, 4, 4 bits. So we have the based on the number of bits, you can set up the priority levels. So the priority, if you have the priority 0, then it has the highest priority. And if you have the priority 1, that is the second priority, and 2 and so on. And we also have the sub priority. For example, if you receive 2 interrupt at the same time, for example, you have the CPU, you are receiving interrupt 1 with priority 0, interrupt with priority 0, and CPU will immediately execute this interrupt signal. And you are receiving another interrupt with also, this is I1 0 and this is I2. This is also with the same priority level. Then the CPU will be confused which one it should execute first. Then it will look at the sub priority level. Maybe this one has the sub priority level 1 and this one have the sub priority level 0. So this one have the preemption also 0 and the sub priority also 0. Then it means this one interrupt 2 has the highest priority. Then the CPU will immediately stop the main program. It will take this interrupt and then it will execute this interrupt. Then it will return back to the main program, or it will go back to this first I10 and then it will finish this one and then it will go to the main program. So here in this one example, I set up the preemption priority as the 1 and then the sub priority as 0. And if I have more Maybe I also use the ADC 3, ADC 4, or maybe the timer 2. So these all are it can generate interrupt signals to the CPU. So I can set up the priority level, whatever I want. So that is the NVIC, to set up the priority level for my interrupts. So then once after you finish this one, then you can go and generate the C code, and then you will be in the C code main program, and then you can edit the code and you can check the output in your LED. So this is for watchdog mode. Watchdog mode will always watch